Surfing is one of the oldest practiced sports on the planet, as the art of waving is a blend of total athleticism and the comprehension of the beauty and power of nature. As surfing is one of the few sports that creates its own culture and lifestyle, it's nothing without the surfboard. The surfboard history began far back as Peruvian fishermen rode waves on primitive boats in the 30,000 BC, which the concept is by then developed in Hawaii. With the growth of surfing settled in the islands, Alaya and Olo surfboards were made solid wood, which was extremely heavy and flat with a square tail. Surfboards were constructed using native wood of the area, as the heavy weight made boards unwieldy for anyone but the strongest and most athletic riders. The surfboards we ride today have been through various processes in order to become as good as they are. With the pursuit of shaping or developing a better board, advances in surfboard design over the years range from weight, size, materials used, and different board design. So what's the best cutting-edge material for surfboards? Polyparaffin-lined terephthalamide, or better known as Kevlar, is a para-aramid synthetic fiber which is used by itself or as a composite material to give added strength, which is also used as reinforcement. Kevlar has high resistance to heat and maintains its strength and resilience to temperatures reaching -196 Celsius. Kevlar is actually stronger at lower temperatures due to tighter bonds between the monomers. At 450 Celsius, Kevlar goes from solid to gas without a liquid stage. Kevlar is a man-made compound and cannot be found in a natural environment. Kevlar is structurally rough as it has low electrical conductivity, high chemical resistance, low thermal shrinkage, high cut resistance, high durability, excellent dimensional stability, as well as flame resistant. Kevlar is a polymer that is made of a large number of the same basic unit called monomers, which by then are connected and repeated to form a long chain. The monomer itself contains 14 carbon atoms, 2 nitrogen atoms, 2 oxygen atoms, and 10 hydrogen atoms as a single chemical bond as well as a double bond. Cross-linkage between hydrogen and oxygen occurs because oxygen is negative, while hydrogen is a positive, where they always attract, forming hydrogen bonds, which is why Kevlar is strong. The crossover connections with the nitrogens and hydrogens that are bonding have given Kevlar its strength as well. Kevlar's chemical structure are formed in tiny straight rods that are packed closely together, as the individual polymer strands of Kevlar are held together by hydrogen bonds, giving Kevlar's unique strength and rigidity. The way of making polyamide is to take an ammonia-like chemical and react it with a certain organic acid, as the process is called condensation, where two substances fuse together in one. The rod-like Kevlar molecules start off in dilute solution, as increasing the concentration increases the number of molecules, yet it doesn't make them align. At this phase, the molecules are still tangled up as they are not extended into straight parallel chains. The basic aramid is then turned into fibers by a process called wet spinning, which involves forcing a hot, concentrated, and very gluey solution of polyparaffin-lined terephthalamide through a spin rod to make long, thin, strong, and stiff fibers that are wound onto drums, as the wet spinning process causes the rods to straighten out fully and align so they're all positioned in the same direction, forming a pneumatic structure. Kevlar is incorporated into the surfboard manufacturing process to strengthen the deck, as creators claim how the composite materials is 6 times stronger than the usual fiberglass used in surfboards, as is strong as a layer of 6 Oz. The use of Kevlar lightens the surfboard itself and is considered stronger, as it offers increased density without the addition of firmness, which greatens the speed. From that, it allows the surfboard to flex while extending the deck and guarding it from getting crushed in. The surfboard will then last 3 to 4 times longer than typical fiberglass or polyester combination because the materials aren't quickly tired. Due to the thickness of the Kevlar cloth, the amount of resin is needed comparing to the conventional fiberglass, which means that there will be an increase in the mass of the board. The fiber themselves absorb moisture, as it by then more sensitive towards its surroundings, unlike glass or graphite composites. Although tensile strength and modules are high, compressive properties are relatively poor. Surfers are known for being progressive, and with this comes experimentation with different shapes and materials with both ethical and unethical sayings. The properties of Kevlar available can allow the surfer or engineer itself to enable in inventing their surfboard with high strength, rigidity, and less weight, as not only are the materials being used are changing, but the method of manufacturing is evolving as well. However, the fear of mass production brought concerns of removing the soul from the sport as the traditional method of hand shaping boards is being reduced to a job of computer.